Hello guys, welcome back to my channel. In this particular video, I'm going to take you through number system conversion. And our first scenario, we will start with the binary integer to decimal conversion. And these are the steps that we take. Step number one, you write down the number. Step two, you write it respective place value starting from the right. Step 3, you multiply each digits with its respective place value. And lastly, you add the product, then write the answer. So let's go to our example. Example number 1, we have binary number 101 base 2. Remember, a binary is supposed to have two digits, that is 1 and 0. And it should always have a base 2. Why does it have a base 2? Because it has two digits, that is 1 and the 0. So step number 1, as per the instruction, you write down the given number, that is 1, 0, and 1. Then the position, you write the respective place value starting from the right. From the right, this is 0, this is 1, this is 2. The counting position always start from 0. Then our base is 2, so it's supposed to be 2 raised to power 0. So the base is raised to power to the position, which is 0. Then 2 raised to power 1, 2 raised to power 2. Then after that, you multiply each digit with its respective place value. 2 raised to power this one, 2 raised to power 2, this is 2, 2 raised to power 1, this, oh no, sorry, this one is supposed to be 4, sorry for this one is supposed to be 4, while 2 raised to power 1 is 2, while 2 raised to power 0 is always 1. Remember the rule? The rules of indices. Any number raised to power 0 is always 1. Okay, after you get that, you multiply each digit with its respective place value. Okay, add the product. Okay, therefore we multiply this one with 1, this one with 0, this one with, so we have number 1. The number is 1 multiplied by 4 brackets plus the other number is 0 multiplied by 2 the other number is 1 multiplied by 1. Okay, this one multiplied by this one, 1 multiplied by 4, this is 4 plus 0 multiplied by 2, this is 0. 1 multiplied by 1 is 1. Therefore, 4 plus 0 plus 1 is giving us 5. So when you convert this number, that is 101 base 2 to a decimal number, it's supposed to give us 5. Okay, whenever now you are writing the final answer, you need now to give the base of that number. This one is supposed to be, this is a decimal number, therefore it's supposed to have base 10. Therefore we can conclude by saying that 0, 1 base 2 is 5 base 10. So we have successfully converted the binary 101 base 2 to 5, 10, which is a decimal number. I hope up to that point we had together. Okay, let's move now to another different example. Okay, so I will wrap this one. Okay, let's move to our number 2. Let me make it a little bit large. Okay. So we have, so step number 1, you write the number. I will be a little bit fast here since you have already learned on how to go about it. You start from the right, that is from 0, 1, 2, and 3. This is 3. It's supposed to be base 2, 2 raised to power 3, 2 raised to power 2. This is supposed to be 2, while 2 raised to power 1, and lastly 2 raised to power 0. Okay, now as we have said, when you raise this one to power, it's supposed to give you 1. 2 raised to power 1 is supposed to give us 2. This one raised to power 2 is supposed to give us 4, while this one raised to power 3 is supposed to give us 8. I hope up to that point we had together. And also, as you continue to watch, don't forget to subscribe. Let's continue supporting the channel by being a member. That is through subscribing. It's free. You don't have to worry that it will deduct anything from your credit card or the debit card. Okay, now let's move to the next step. Now, after you get this one, the next step is to multiply with the number. That is the first number is 8 multiplying by 1. This one multiplying by this one plus 4 multiplying by 1 plus 2 multiplying by 0, and lastly 1 multiplying by 1. So this one multiplied by that is 8 plus 4 multiplying by, it's supposed to give us then we have this one 2 multiplying by 0 is supposed to give us 0 plus 1 multiplying by 1 is supposed to give us 1. Then you had 4 multiplying by 8 is 12 plus 0, 12 plus 1, you get 13. So our answer is supposed to be 13. Remember, this is a decimal, supposed to have base 10. Therefore, the final answer is supposed to be 1, 1, 0, 1 is base 2 is 13 base 10. Remember always to include base 10 for all decimal numbers and base 2 for all binary number. So this is not the final answer. Okay, let's move to the next example. Our example 3 is supposed to be 1, which is 1 0 0 1 0 0 and 1 1 0 0 1 0. Okay, the position, this is a position 0 1 2 3 4 5 and lastly 6. Okay, then we get this one is supposed to be 6 raised to power, sorry, supposed to be 2 raised to power 6, which is supposed to give us 64. I'm trying now to make the work look a little bit easy and also neat. Then for this one, this is 2 raised to power 5, which is supposed to give us 32. While this one, this is 2 raised to power 4, which is supposed to give us 16. While this one raised to power 3, it's supposed to give us 8. While 2 raised to power 2 will give us 4, while 2 raised to power 1 is supposed to give us 2, and lastly 2 raised to power 0 is supposed to give us 1. As usual, the rule of integers, anything raised to power 0 is always 1. Okay, now having done that, now let's move to the next part, to multiply. Therefore we'll have 64. This is 64 multiplied by 1 plus 32 multiplied by 0 multiplied by 16 multiplied by 0 plus 8 multiplied by 1 plus 4 multiplied by 0 plus 2 multiplied by 0, and lastly 1 multiplied by 1. Okay, this one is supposed to give us 64 plus 0 plus 0 plus 8 plus 0 plus 0 plus 1. So we have this 64 multiplied by 1 is 64, 32 multiplied by 0 is 0, 16 multiplied by 0 is 0, 8 multiplied by 8 is 1. Then we have 64 plus 8 plus 1. 64 plus 8, which is giving us, so this is 72. 72 is our, is it 72? 64 multiplied plus 8 is 72 plus 1 is 73. It's supposed to give us 73 base 10. Therefore, the final answer is supposed to be 1 1 0. No, this is 0 0 0 1 0 0 2 is supposed to give us 72 base 10. So thank you for taking time to watch. So those are the steps that we take whenever you want to convert binary to